projects. In this video, we are going to explain about the project, which is Food and Therapy Recommendation System for Autistic Syndrome using machine learning techniques. So first, we will discuss what is the project about. Autistic syndrome is also called as autism spectrum disorder, which is a complex developmental condition that affects an individual's social skills, communication, and behavior. It typically appears in early childhood and lasts throughout a person's life. Individuals with autism may have difficulty in understanding social cues, expressing themselves verbally or non verbally, and may engage in repetitive behaviors or have narrow interests. In this project, we aim to develop a food and therapy recommendation system specifically tailored for individuals with autism spectrum disorder. This system will assist caregivers, parents, and individuals with autism in making informed decisions about dietary choices and therapy options that may positively impact their well being and quality of life. Traditionally, caregivers and parents of individuals with autism have relied on trial and error or general recommendations for managing dietary preferences and therapy options. However, this approach can be time consuming, costly, and may not always yield optimal results. Additionally, access to specialized therapists and nutritionists who understand the unique needs of individuals with autism can be limited. The proposed system will leverage machine learning techniques to analyze data of individuals with autism. The proposed system will leverage machine learning techniques to analyze data from different age groups, which is adolescent, adults, children, and toddlers with ASD to generate personalized food and therapy recommendations. By incorporating algorithms that can identify patterns and correlations in this data, the system will generate personalized recommendation system for food choices and therapy options tailored to each individual's needs and preferences. Machine learning techniques play a crucial role in addressing the complexities of autism spectrum disorder. These technologies can analyze large data sets, identify subtle patterns, and generate personalized recommendations based on individuals' characters and responses. Machine learning models can continuously learn and adapt, allowing the recommendation system to improve over time as more data becomes available. The objective of the project is to develop a personalized food and therapy recommendation system for individuals with autism spectrum disorder, aiming to tailor interventions to their specific needs and preferences. The goal is to employ various machine learning algorithms, including voting classifier, LDA, SBC, logistic regression, naive Bayes, KNN, decision tree classifier, random forest classifier, and ADABOOS classifier to analyze and forecast dietary and therapeutic recommendations for individuals with autism spectrum disorder. The aim is to predict the presence of autism spectrum disorder based on input features related to individuals' characteristics and behavior, and subsequently recommended personalized food and therapy interventions to optimize their well being. The objective is to assess the performance of the recommendation system using standard evaluation metrics, which are accuracy, precision, recall, and FN score, to gauge its effectiveness and reliability in accurately predicting ASD detection and suggesting appropriate interventions. The goal is to provide individuals with ASD with personalized food and therapy recommendations, potentially enhancing their quality of life. Additionally, caregivers and healthcare professionals will benefit from a dependable recommendation system, simplifying the process of finding suitable interventions and improving treatment effectiveness. To implement this project, we need software and hardware requirements. So, coming to the software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. So coming to the hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. So coming to the first step, which is importing the packages. In this step, necessary Python libraries like Pandas for data manipulation, Seaborn and Matplotlib for visualization, Scikit-learn for machine learning algorithms, Flask for web development, and SQLite for database management are imported. The next step is exploring the dataset. This phase involves understanding the structure and content of the dataset. We have imported adolescents dataset, adults, children, and toddlers dataset. They are of different age groups. This exploration helps in identifying relevant features and understanding of the data quality. Coming to data processing, here we have converted data into Pandas data frame. The dataset is loaded into Pandas data frame, which is tabular data structure that allows for easy manipulation and analysis. We also remove duplicate values. Here, any rows with missing or null values are removed from the dataset to ensure data integrity and model performance. The next step is visualization using Seaborn and Matplotlib. Seaborn and Matplotlib libraries are utilized to create visualizations such as histograms, bar plots, and scatter plots. These visualizations aid in understanding the distribution of the data, identifying patterns, and exploring relationship between variables. The next step is label encoding using label encoder. Categorical variables in the dataset are encoded into numerical representations using label encoder. This step is crucial as many machine learning algorithms require numerical inputs. Coming to feature transformation, quantile transformer, power transformer, maxab scaler, and normalizer are the techniques used for feature scaling and transformation. Feature scaling ensures that all features are on the similar scale, which can improve the performance of certain machine learning algorithms. The next step is splitting the data into train and test sets. The data set is divided into two subsets, which is training set and the testing set. The training set is used to train the machine learning model, while the testing set is used to evaluate model's performance on unseen data. Coming to building the model, in this step, machine learning algorithms are initiated and constructed. Training the model. In this step, machine learning models are trained on the training data. During training, the model learns patterns and relationships in the data. The next step is Flask framework with SQLite for sign up and sign in. Flask, a web framework, is used to develop web applications. SQLite, a lightweight relational database management system, is used for storing user authentication information like usernames and passwords. This allows users to sign up and sign into the application securely. The next step is user gives input as feature values. User provide input values for the features relevant to the model. These features are necessary for making predictions. The next step is given input is pre-processed for prediction. Pre-processing steps such as label encoding and feature transformation are applied to the user input to ensure compatibility with the trained model. The next step is trained model is used for prediction. The pre-processed input data is fed into the trained machine learning model to generate predictions. The last step is final outcome is displayed through front end. The prediction outcome is displayed to the user through the front end of the application. This includes insights, recommendations, and other relevant information based on the input provided by the user. Algorithms which are used in the project are voting classifier. It is an ensemble learning method that combines the predictions of multiple base classifiers to make a final prediction. There are two main types of voting. One is hard voting and the other is soft voting. Coming to hard voting, where each classifier prediction is counted as a single vote, and the soft voting is where the probability estimates of the classifiers are averaged to make predictions. In this project, voting classifier is utilized to leverage the collective wisdom of multiple machine learning algorithms. The next algorithm is linear discriminant analysis. It is a dimensionality reduction technique used primarily for classification tasks. It seeks to find the linear combinations of features that best separate different classes while minimizing the variance within each class. LDA projects the original feature space onto a lower dimensionality subspace, maximizing between class separability and minimizing within each scatter. It is chosen as one of the base classifiers due to its ability to transform the feature space in a way that enhances class discrimination. The next algorithm is support vector classifier. It is also known as support vector machine and it is a powerful supervised learning algorithm used for classification tasks. SVC works by finding the optimal hyperplane that best separates different classes in a feature space. It aims to maximize the margin between classes while minimizing classification errors. By utilizing kernel functions, SVC can map original feature space into a higher dimensional space where classes become linearly separable, thus enabling it to capture complex decision boundaries. In the context of this project, SVC is chosen for its ability to accurately classify individuals with ASD based on their features, even in scenarios with complex relational between features. Coming to logistic regression, it is a supervised algorithm used for binary classification tasks. Despite its name, it is primarily used for classification rather than regression. Logistic regression models the probability of the outcome variable based on the one or more predictor variables. It uses the logistic function to map directions, predictions to the probabilities. Logistic regression can provide insights into the relationship between predictor variables and the likelihood of ASD, making it valuable for understanding the underlying factors and contributing to the condition. Coming to naive Bayes, it is a probabilistic classification algorithm based on Bayes' theorem and the assumption of feature independence. Despite its simplistic assumptions, naive Bayes can surprisingly effective in practice, especially for text classification and spam filtering tasks. It calculates the probability of each class given a set of input features and selects the class with the highest probability. Naive Bayes can effectively model and the probability of an individual having ASD based on their features, taking into account the independence assumption. It is particularly useful when dealing with a large dataset and when feature independence is a responsible assumption. The next algorithm is k nearest neighbor. K nearest neighbor is a simple non-parametric classification algorithm used for both classification and regression tasks. KNN makes predictions by identifying the k nearest data points in the feature space and taking a majority vote or computing the average for their target values. KNN's ability to adapt local structure of the data makes it valuable for capturing complex patterns in the dataset, potentially improving the accuracy of ASD classification. Decision tree classifier. It is a supervised learning algorithm used for classification tasks. It works by recursively splitting the dataset into subsets based on value of features with the aim of maximizing the homogeneity of the target variable within each subset. The final outcome is a tree-like structure where each internal node represents a decision based on feature and each leaf node represents a class label. They can capture nonlinear relationships and interactions between features, making them valuable for understanding the complex decision boundaries associated with ASD diagnosis. Coming to random forest classifier, it is an ensemble learning method based on principle of bagging, which is bootstrap aggregating. It builds upon multiple regression, which is decision trees during training, and combines their predictions through averaging for regression or voting for classification to improve predictive accuracy and reduce overfitting. Random forest classifier is chosen as the one of the base classifiers due to its ability to handle high dimensional data, non-linear relationships, and mitigate the risk of overfitting associated with individual decision trees to provide robust predictions for ASD diagnosis. The last algorithm is AdaBoost classifier. AdaBoost is adaptive boosting. It is an ensemble learning method that iteratively combines weak learners, typically decision trees, to create a strong learner. It assigns higher weights to misclassified instances in each iteration, thereby focusing on harder to classify instances in subsequent iterations. By sequentially training weak learners and adjusting their weights, AdaBoost can enhance the robustness and generalization capability of the model, making it suitable for ASD diagnosis and tasks. We have used accuracy, precision, recall, and FN score, which are the performance metrics to evaluate all the models built in the project. So here in the project, we built all the models for all the transformation techniques for all the four datasets. So here we have comparison graph for the adolescent dataset for the technique quantile transformer technique. So here we have accuracy comparison graph. Here in the comparison graph, x-axis represents accuracy score for each algorithm and y-axis represents all the algorithm names. Similarly, we will have for other graphs also. Coming to accuracy, it is the proportion of correct predictions in a classification task measuring the overall correctness of a model's predictions. This is precision score comparison graph. It is the ratio of true positive predictions to the total positive predictions, representing model's ability to correctly identify relevant instances while minimizing false positives. This is recall comparison graph. Recall is also known as sensitivity or true positive rate. It is the ratio of true positives to the total actual positives, measuring model's ability to capture all relevant instances without missing any. This is FN score comparison graph. It is the harmonic mean of precision and recall, offering a balanced measure that considers both false positives and false negatives, making it suitable for imbalanced datasets. Here we have comparison graphs for power transformation technique for adolescent dataset. This is for max abscaler technique for the same dataset, and this is for normalizer technique. Similarly, we will have for other datasets also. So the algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we have to open the code folder which contains source code files. This is the code folder of the project. This is the dataset folder in which we have all the four datasets. We use all these datasets for training the algorithms. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. This is the models folder in which we have algorithm information and that will be loaded into the project code during runtime. This is the IPYNB file and we have multiple IPYNB files for all the four data sets. So these are the Jupyter Notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the signup.db file. This file is the database file used to store the user information. Now to execute the project, we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we have to open the Anaconda prompt. Using the cd command, followed by the space, we need to paste the copied path and then click on enter. This will change current directory to the code folder's path. And here we need to type the command app python space app.py to compile app.py file. And now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now we have to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built using the Flask framework. So to execute the project, first we need to sign up if you are the new users. So click on sign up and enter all the registration details if you are registering newly. I have already registered and I have an account in it, so I'll directly sign in. So click on sign in. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password. Now click on sign in. We have signed in successfully and we are redirected to prediction page. As I already mentioned that we are going to do prediction for all the four data sets. So first we'll do prediction for adolescent data set. For that under prediction, click on adolescent link. Here we can see the questionnaire which has to be answered by the patient and fill all the personal information. So now we will do that. So here I have answered all the questions of a patient and I have entered his personal details. Now click on predict. Here we got the prediction that the patient has no autism spectrum disorder based on provided input. Now we will try giving the other patient details. So under prediction, click on adolescent again. We will fill in all these details of other patients. I have answered all the questions and the details of the patient. Now click on predict. As a person has autism spectrum disorder, it is asking to provide the symptoms of the patient to provide food and therapy recommendation. So from the symptoms list, I'm selecting the first symptom and now click on submit. So here we got diet and therapy suggestions. Here we have diet suggestions and therapy recommended is occupational therapy for the patient. Now we will do prediction using other data set. For that under prediction, click on adult screening. So now we are doing prediction for adult screening data set. Similar to adolescent data set, here also we have questionnaire which has to be filled by the patient and the personal details. So now we will be filling them. I have given answers to all the questions and I entered the details of the patient. Now click on predict. Here it is showing that autism spectrum disorder is detected to the person. So here it is asking for the symptoms to provide. So from the symptoms, I'm selecting decreased eye contact, social avoidant behavior, and communication disorder. Now click on submit. Here it has given diet and therapy suggestions. This is the diet suggestion for the patient and the occupational therapy is recommended. Now we will try giving the other patient details. So from the prediction, click on adult screening. So I have filled all the details. Now click on predict. Here we got the prediction that patient has no autism spectrum disorder based on provided input, which means that is not suffering from autism disorder. Now we will try using the other data set. So under prediction, click on children link. So here I entered all the patient details. Now click on predict. So here we got the prediction that the patient is not diagnosed with autism spectrum disorder based on the given input. So now we will provide other patient details for the same data set. So click on children again. I have given answers to all the questionnaire and I have entered all the personal details of the patient. Now click on predict. As the patient has autism spectrum disorder, it is asking to provide the symptoms of the patient to provide food and therapy recommendation. So from the symptoms drop down, I'm selecting blood lead. Now click on submit. So here it is not showing any suggestions. Now we will try with the other patient details. So for the same data set, click on children. I have filled all the details. Now click on predict. So here, as the autism spectrum disorder detected, it is asking to provide symptoms. So from the drop down, I'm selecting poor quality sleep and sleeping disability as the symptoms. And now click on submit. Here we got diet and therapy suggestions. Here is the diet suggestion. And here we have occupational therapy recommended. Now we will do prediction for the other data set, which is toddler form. So click on it. Similar to other data sets, here also we have the questionnaire which has to be filled and the personal details of the patient. So now we will fill them. So here I have filled all the details. Now click on predict. Here we got the prediction that autism spectrum disorder detected and it is asking for symptoms. So from the symptoms drop down, I'm selecting frequent bowel movements and bowel movement irregularity. And now click on submit. So here we have diet and therapy suggestions. This is the diet need to be followed by the patient. So now click on sign out. In this way, just by entering the parameters and answering questionnaire, we will get the prediction whether autism spectrum disorder detected or not. If it is detected, it will recommend food and therapy suggestions. So the conclusion of the project is the project has been successfully developed to create a personalized food and therapy recommendation system for individuals with autism spectrum disorder. It incorporates various machine learning algorithms to analyze data, generate personalized recommendations, and improve the well-being of individuals with ASD. Among the algorithms used, random forest classifier emerged as top performer in terms of predictive accuracy and robustness. Its ability to handle high dimensional data, capture complex interactions between features, and mitigate overfitting made it particularly effective for tasks of ASD diagnosis and recommendation. For the Flash-based front-end of the recommendation system, random forest classifier is deployed as the primary algorithm. Its reliable performance and ability to provide accurate predictions makes it an ideal choice for delivering personalized recommendation to users. In the future, the project could explore integrating advanced deep learning models to enhance prediction accuracy and recommendation quality. Additionally, expanding the recommendation system to incorporate real-time data streams and adaptive learning mechanisms could further personalize interventions for individuals with autism spectrum disorder.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.